Hello, everyone. I hope you all are keeping well and doing great. Welcome back to the lesson 8 in the chapter 3, that is differentiation. The lesson 8 is about implicit differentiation and inverse trigonometric functions. A quick reminder, if you have not watched the previous lessons, please go back and watch them. Say, for example, if you have not understood the lesson 3 in the chapter 3, it's very hard to understand this. You need to watch one by one in continuity. After lesson 3, you understand properly, then go to the lesson 4, and then the next and the next. This is a bit different one, not a unique one, it's just a interesting one because till now when we have differentiated or derived, we had only one term with respect to x only. Now there'll be two variables. We will look into this, but before that, the learning objectives of this lesson are to find derivatives implicitly and to use implicit differentiation to find derivatives of inverse trigonometric functions, and then to solve mathematical and real world problems using implicit differentiation. Now the keywords are explicit function, implicit differentiation. These are the things. Now before we begin, let's just jump in. Okay, implicit differentiation. What is this word explicit and implicit? Just take a moment and think about it. You might you might know what is explicit and implicit in just normal English in day-to-day words. Just think about it. Now, explicit is something that is explained thoroughly. You explain in detail, whereas implicit is something that you're implying. So you're not exactly telling it, but you are thinking you understood. It's implying something, right? So explicit is just what we have done before. It was like so easy, thoroughly done. But here now, we are deriving with respect to dx. We always did this d by dx. But there are two functions. One function is with respect to y and with respect to x. There are two separate functions. Now, in simple terms, if I'm going to write this, say here, we need to find, we have y at the left side and we need to find xy square. Sorry, let me take it as plus now, then it'll be easier. Sorry, okay, let me just remember this. So this f of x is equal to x plus y square. Now here, f of x, we write it as y equals x plus y square. We know how do we do derivation, d by dx on the left side, and then we derive at the right side, right? When we write this, both the terms must be over here, d by dx. So what happens now? Here it will be y dash. See, y dash, that is what, but with respect to x, so we can write it as y dash of x. That is equal to, here when we derive the first term, it will be dx by dx. What is the differentiation? Or you can just let me remove this. It'll be d by dx of x. Okay, we know when it's power 1, it's 1. Then here again we have d by dx of y square. So the left side is done, y dash of x. That is what we are solving for. This side is 1, but what about this? Use the power rule. What is the outer function? Like a layer outer function, chain rule. This is the outer function. It is 2y. If it was, say, just look over here, if it was x squared, it would be 2x. And that's it. Why? Because then if we do chain rule for the inner function, derivative of x would be 1. So we don't write that. It's just 2x, right? But here, since it is not x, it's y, after writing this, we write y dash of x again. So here you can see when we differentiate on both the sides of the equation, we are getting y dash. Now such terms are called implicit differentiation. Now basically to solve this, how would you solve it? You can do one thing is take this to the other side. It would be y dash of x minus 2y into y dash of x. See, 2y into y dash of x. That will be equal to 1. Now look here, y dash and y dash can be removed common, isn't it? You can remove y dash of x outside, and what would happen? It would be 1 minus 2y. This is what we will be doing. We will see this in detail, but it's just that you need to remember both the side there will be y dash. We need to group them together and remove that common out and then solve it up. This is about implicit differentiation. Now, one thing you need to understand, we have the term x and y. See, like over here, x and y. Okay. We will look into a problem you'll understand much better now. Here, you need to find y dash of x. The first thing to do such problems, because both the sides, if you take this to the other side, there'll be y on both the sides, or there is y and x. That's the most important thing. Whenever you have x and y, it's different thing. We need to derive this on by differentiating on both the sides, and then we need to solve it. We'll do it one by one, and then we'll find the equation of the tangent line. We have done the tangent line many times before. That is pretty straightforward. If you know a formula, x and y is given, easy to solve. But this is implicit differentiation. Now here, look at these terms. Let's differentiate on both the sides, this left side and right side. I'll directly write it, d by dx on left and d by dx on right. Okay. So what happens? This term is differentiated at the left and right. Since it's plus, it's simple. It'll be 2x. I don't write again x dash because when you derive x, it is just 1. So that's it, 2x, that's it. We have done this many times before. But now, a easy way to remember is, when you derive any y term, use the power rule. Okay, it'll become 2y. 3 comes down, y, 3 minus 1 is 2. Now always add y dash of x. Whenever there is y, you're always adding y dash of x. Why? Because this y dash of x is what we need to solve. That is d by dx of y. Okay. So that is the thing. But if you don't understand, if you don't understand, that's fine. But just remember, do differentiation as it is for x. Only for y, do it normally, but add this y dash of x. Then what happens? Minus 2. If it was just y, it's 1. Okay, but now, if it was just x, it was 1. That's it. 2 is the answer. 2 into 1, that's 2. But since we have y, you need to add y dash of x. That is equal to, now, it's not 3. Differentiation of a constant is 0. This is the answer. But now you need to find y dash, right? You can see there is y dash here, y dash here. What you need to do is, whenever you see any term with y dash, you need to group them together. And what I'll do over here, whatever is not there, I just remove to the other side. Okay, I'll take this to the other side. So what is remaining? I'll use the same color and then only I'll write over here 3y square minus 2. Why not write y dash? I just want you to know it is, this is the most important term which I need, so I am grouping them together, leaving these two over here. Why? Because there is y dash in these terms. When it is multiplication, it's all one term. Only plus or minus separates the terms, right? Now this is 3 terms, but this is altogether 1 because it has y dash multiplied with this. Okay. Now this 2x, I'll take it to the other side. It becomes minus 2x. Now what next? This y dash, very crucial term. I take it out common, y dash of x. Once I remove that, what is remaining? The remaining parts are 3y square minus 2. That is equal to minus 2x. It's very simple. If you know distributive property, you know that when I multiply this inside, because there is minus here, this will be multiplied to both the terms. It will be 3y square into y dash and 2 into y dash. It's just that now I know there are two common terms, I remove it out. That's the only thing. It's basically like 2xy plus 3y. What we can do, we can remove this y and y out. It will be 2x plus 3, isn't it? Even with numbers, if you have say 6 over here, I can remove 2 outside. Then this 2 is gone and over here it will be 3. Why? Because if you multiply this 2y inside, it's going to be 2xy plus 2 times 3 is 6y. It's going to be the same question. This is the concept, distributive property. Now what you do, we wanted y dash only, right? I want only this y dash. I don't want anything else. So you need to leave this y dash of x here and write everything else to on the other side. Minus 2x over here. This goes down because it's multiplication. Here it's multiplication. It's multiplying. I'll write a small x. That's multiplying. Okay. And now when you take this to the other side, it becomes division. It will be 3y squared minus 2. So this is your answer. That is what is y dash. That is how you solve y dash. But now this is the slope. Y dash of x is the slope basically. But it's still not over. Why? Because they told to find the tangent line. And they have given you x and y. So over here x is given, y is given. Substitute in this equation and find the value of slope like a number. Okay, minus 2 into 2 divided by 3 into 1 square minus 2. It'll be minus 4 by 3 minus 2 is 1. That's minus 4. This is the slope in terms of numerical value. Now it's still not over. There's a little bit remaining now. I hope this is clear so far. Here, what happened? We found the y dash, we substituted the x and y values. Instead of x it is 2 and instead of y we put 1 and solved it. We got the slope to be y minus 4. Y dash of x is basically the slope. The derivative of a function is its slope, right? Yeah. Now then, tangent line. Do you remember the formula of the tangent line? It is given by y minus y naught equals m into x minus x naught, or some variation of this. Okay, it might be written differently over here, y1 or something, but ultimately it's the same thing. You don't do anything with x and y. Other things you need to substitute. We know this is initial values given, x naught, y naught. Now what I'll do is y minus, what is y naught? It's 1 equals, what is m value? Minus 4 into x is as it is. X naught value is given in the question. We substitute. This is the answer. Or you can just multiply this inside and do the distributive property, or you can just leave it because I think it's not done anything further. Anything. One second. We'll just compare answers. Y dash of x is minus 2x by 3y squared minus 2. Yes, we got the same thing. And then slope was minus 4. Yes. And they have just written this as it is. Look over here. That's the answer. But now I will just do another step over here, because sometimes if this is an MCQ, for example, you have multiple choice, this is not there in your option. Then remember y minus 1, this side will be multiplied inside sometimes. It will be minus 4x, minus and minus becomes plus 8. This is also the answer. Or you can just take it to the other side. It will be minus 1 to the other side would be plus 1. So it will be minus 4x. 8 plus 1 is plus 9. All these are the answers. It depends on which is given in your question. But see now, in this example, the first part only is given in the question. You can stop over here itself. After finding the slope, we found out over here, that is the answer. So this is how you find the tangent line, okay? So that's the answer for this problem. Now we have one more problem here, same like just now. It's just that we have to again find the equation of the tangent line. Now we have to use implicit differentiation. Let's do the same thing again. But before that, I would highly recommend you pause the video and try to do it by yourself. If you're trying to do by yourself, just remember here you need to use product rule, and then it's straightforward otherwise. Okay. Now we will do it here. Differentiate on both the sides. So what's going to happen at the left? Look, this is uv. The product rule, uv is equal to u dash v plus uv dash. So now that means I have to derive the first term at the beginning. It will be 2x multiplied by the second term, y squared. Then plus here the first term will remain the same. The second term will be derived. It will be 2y into y dash of x. Why do I write y dash of x? Because it's y. X doesn't matter. Then next would be minus 2 because it's x, right? X becomes 1. It's just minus 2. If it was y, you ought to add y dash of x equals 4 will be 0 minus 4. See, now it's just not minus 4. It will be y dash of x. If this was x, it would be minus 4. So you can see the difference here. Minus 2x, it's just minus 2. Whereas it's minus 4y, it's not only minus 4, y dash of x must be multiplied. Now you can see there is y dash here and over here. What you need to do, get them together. You can either keep this over here or this to the other side, and the term without y dash of x, bring it to the other side. So you can see this term as y dash of x and this term as, this is 0 is not this, so this is the only term. So what I'll do is I'll write these two terms over here. It'll be x squared into 2y, and I'll write it in different color for y dash just to highlight it. Since this is minus, when it goes to the other side becomes plus. Okay, y dash, I'll write it in some other color. Let me use this one. It'll be y dash of x, y dash of x. Okay, you can see in the pink it's written y dash of x because these are the only two terms with y dash of x. Then let us write the remaining terms, all the constant terms in black here. It'll be 2, positive 2 when it goes to the other side, and it'll be minus 2xy squared. I hope this is clear. I'll repeat it now. You can see when we derive this by using the product rule in the first term, we get these two terms, and then it's minus 2 equals 0 minus 4y dash. We have 4 terms remaining. Whichever is having plus and minus, it will separate the term. 0 is gone. Get the y dash terms. So you can see this y dash of x, get them together. So I left this over here and the negative term, I brought it together over here in the left side. You can see both as y dash, which is in pink. And all the other terms without the y dash, I took it to the right side. Minus 2 becomes plus 2, and this 2xy squared becomes minus 2xy squared. Now what you need to do, remove this common out. Y dash of x, I'll remove it common out. I'll use the pink again. Y dash of x is removed common. And what is remaining? You're remaining with x squared 2y plus 4. That is equal to this side, 2 minus 2xy squared. And now this term, you just take it to the other side. It will be, the final answer will be y dash of x equals 2 minus 2xy squared divided by x squared 2y plus 4. This is the answer. This is the slope. Let's just double check answer quickly. 2 minus 2xy squared by 2x squared y plus 4. That's correct. I've just written x squared first and 2y. It's fine. However you do, the answer will not be different. As long as you know when it's multiplied, they're all a single term, so they will be ultimately multiplied together. Now then we have x and y values, right? Let's just put them in this equation. See over here, it is x, y. Let's put them in the equation. Let me just change the color. So y dash of x would be equal to 2 minus 2. Now what happens with the x value? X value is multiplied by 2, and the y value use minus 2 whole square. Now again back, remaining as it is we x squared. So x squared, I'll just write, I'm just doing the different colors so you understand. X is 2, so I'm substituting wherever x is there as 2 in black color. It's 2 squared. This is a constant that was already over there, no difference. Now the pink color is the y value, that is minus 2. It is multiplied with minus 2 now, plus, let me use the blue color back, it's plus 2. I hope this much is clear. Now we have to just simplify this. 2 remains, you can put in the calculator directly and solve it. It's better you put in the calculator, don't do any unnecessary mistakes. 2 times 2 is 4, minus 2 squared becomes positive 4. It'll be 4 times 4, it's 16, minus 16 divided by 2 square. Over here again, it's the same thing, 2 square is 4. But here, minus 2 times 4 is minus 4. 4 times minus 4 is minus 16. Over here, why it's minus? Because of this sign. This minus dissolves, only one minus sign remains. Plus 2, the answer would be, it'll be 1, because 2 minus 16 is minus 14 divided by minus 16 plus 2 is minus 14, and minus minus cancels, 14 by 14 is 1. That is the slope. Now you can directly put in calculator and you will get the answer directly as 1. You can see the slope is, sorry, my bad. So the lesson learned, always use. Okay, what I have done over here is, it's good that I made this mistake. It's a very silly mistake, but it would lead the entire answer wrong. You can see over here the question, the slope is having plus 4, but I forgot to write the 4 value. What did I write? I wrote 2. That's the reason it was entirely wrong. This is 4. Now you can see it be plus 4 and the value will change. But now I will just use the calculator. I will just simplify this 1 second and then I'll use the calculator. Here it is minus 14, same thing. Down it is minus 12. This is minus 12. Now you need to simplify this. Minus minus goes, it'll be two tables goes, it'll be 7 by 6. I think so, that's correct. It'll be 7 by 6. Yes, that's the correct answer. So sorry for the mistake here. I hope this is clear. This is wrong. Most important thing, see, if it comes for writing, it is how you derive this implicitly. If you get this all right, most correct, then it's just substituting over here. You don't even need to do this step. You can directly put this in calculator and solve. You'll directly get the slope. Make sure you do this implicit differentiation accurately, each step. Double check them. Okay, don't do very quickly. Take your time, think and answer each step. Now, once that is done, you just substitute this x and y value in the slope, that is y dash of x, and you get the numerical value of the slope. That is 7 by 6. I'll remove this because there's too much. Here, once we found out that that's 7 by 6, now you should just remember the slope equation, the point slope equation. I'll just write it out over here. It is y minus y naught equals m into x minus x naught. It's minus. And now we know this y value will remain as it is, but y naught is given here. This given values are considered as x and x naught, or x and y, just for understanding. Now y naught is basically minus 2 equals m is 7 by 6 times x minus 2. Here you can simplify this, will be y plus 2 equals, you can multiply this inside, but generally see your options and then do accordingly. If it's writing this step, the first step is more than enough, that would be the correct answer itself. But over here, it's just that minus and minus will be plus. So we have written y plus 2 equals 7 by 6, x minus 2. So this is your answer. I hope this is clear. So you can see the tangent line over here. That's the thing. The positive slope shows it up. And these are this is the tangent line. That's the answer. Now we have a real world situation problem. Let's do this quickly. Even if the graphs are not given, only from this equation you can find. And they're not going to ask you these graphs because it's very crazy to graph them. It'll take you like a long time, like forever. So don't worry about the graph. This is just for understanding. Okay, but the equation, whatever I wrote just now, only those are the most important thing. Writing this and the derivation, that is what they'll ask you, and assess. You'll be marked on that. Okay, unless and until they specifically mention graph this, because now this graphing you can do a table and graph it. It's not a big deal, but it just takes so much time because of the the variations of these graph, the way it is structured. It will take a long time. We move on to the third example problem. Honestly speaking, what happened is I did this problem just a while ago, and I went to the last step and then I realized a silly mistake done by me ruined the entire problem. So I'm doing it again. I'm recording this part again. So most important thing what I want to tell you is Just be very careful in each and every step. A simple sign or a simple term, if you miss out a single term, the entire question is going to be wrong. And it's very hard for you to figure out what. Rather than going back and telling this is the mistake, it's better to do it afresh. So if you have done the same mistake, if you're doing it in the exam and you missed one single point, try to understand what's the mistake and do it all afresh, like write it from the beginning and solve it. Now we will move on to this. Here, we have been told that under certain conditions, van der Waals equation relating the pressure P and volume V of a gas is given over here. There is a inverse relationship between the pressure and volume. Sorry, not inverse. There is a relationship between pressure and volume. It depends on various conditions. And here, this is based on van der Waals equation at a particular condition. Now, assuming this can be, this equation implicitly defines the volume V of a function and the pressure P. Use implicit differentiation to find the derivative dV by dP at this particular point. Whenever such problems are there, what I personally like to do is change it to x and y, because I generally solve problems on in x and y so many times. So whenever it's x and y, it's easy for me. Now if you keep it like this, you can do it. But sometimes now, because implicit derivation, you know that y dash of x must be added, you might be confused which is x, which is y. So what I personally would suggest, change it to x and y. How do we do that? I'll let you know. uh, we need to find dv by dp, right? So we know y dash of x, that is equal to dv by dp, or we know y dash of x is dy by dx. So from this concept, we know y is v and p is x. So this is that you can easily change it up. So since I'll be implicitly deriving it, let me just come over here because there's plenty of space to write down. Now I would just change this terms p as x. So this will become x plus phi. Now what I will do is, instead of divided by v square, I'll take this up. It will be v negative 2, and I know v is y, so it'll be y minus 2. It's just that I'm bringing it up. This is 1, and over here next one, y is v, so y minus 0.03 equals 9.7. Okay, let me just erase this all because we already used it. Now then, looking at this, this is a binomial, but they are multiplied to each other, so we need to use the product rule. I'll just show over here. This is u v, and we have to use u dash v plus u v dash, and now then we will do that. Just be careful in each and every step, because a few minutes ago I did it all, and one step, that to a single term, sometimes not writing it clearly or not multiplying this negative 2 over here would be 10 and all that simple things will lead to an error, and it's very hard to figure out the error. So what I'll do over here is try to do it slowly and each step by step. So we have to use the product rule. What is product rule? The first term derived, u dash. So here let me derive this term, this entire term. It would be 1, x will be 1 plus, derive this. The power rule states that whatever is the power comes down, it multiplies here. So it'll become minus 2 times 10 will be minus 10. So this will become 1, not plus, it will be minus 10 y to the power minus 3. Okay? Why? Because it'll be power minus 1. Minus 2 minus 1 is minus 3. It's not over since it's y implicit derivative. Multiply it with y dash of x. This is the term. Most of us will miss this many times. I have done this mistake, missing in implicit derivation. I forget to write y dash of x. So whenever you see an implicit problem, okay, there is something to remember. What is that? Y dash of x. So always keep that in mind. So I derived y dash now. This entire thing is a single term. Now what is the next term? V. What is v? You need to write v as it is, 0.03. Now plus, so these are entire term. I need to multiply this inside. Now plus, what is there? u term will remain as it is, x plus 5y minus 2 will remain, and derive this term. When you derive this, it will be y dash of x, and this becomes 0. That's it, equals 0. Okay, that's the thing. Now, when you're doing distributive property, do it properly. Okay, don't get confused. One term. No, this entire term I'll multiply over here now with 1, so it's going to be the same thing, y minus 0.03. Okay, this is one term, first term. I'll just write minus. Now this term again is multiplied over here, so it'll be 10 y to the power minus 3 into what is remaining. What is this? I'll write this at the end, so that's why y minus 0.03 y dash of x. Then last term is plus x plus 5y to the power minus 2 into y dash of x. I'll just use the other color to show this multiplied here. See, this first time it's multiplied here with 1, and this is what we get. Next, again, that thing is multiplied with where? Over here, the second term. So that is where we get this. Okay, sorry, it should be a little bit up. So minus this. And this last term over here, let me use this color. This is the last term. Oh, sorry. Here, this one over here, and this one over here. I hope this is clear so much. Now then, we will continue it. Here we need to group y dash terms. So this is y dash and this is y dash. So only keep them together and remove all the terms to the other side. So I'll write y dash, that is minus 10y to the power minus 3 into y minus 0.03 into y dash of x plus x plus 5y minus 2, and it will be y dash of x over here. Okay, that's the second term. This first term, I'll take it to the other side, will be y minus 0.03. Now, let's take this y dash and y dash common out. Y dash of x is removed. So, entire thing will be a single term now. It'll be minus 10 y to the power minus 3 into y minus 0.03 plus y dash is gone outside, plus what is remaining here, x plus 5y to the power minus 2 is remaining. That is equal to y minus 0.03. Now take this entire term to the other side denominator. You will get y dash of x equals y minus 0.03 divided by all this term. It will be minus 10 y to the power minus 3 into y minus 0.03 plus x plus 5y power minus 2. Now, this is the y dash of x, or whatever they have given in terms of p and v, that is dv by dp. This is dv by dp, derivative of that. I just realized one thing. Even now, I did a mistake. I'm sorry for that. Look here. I removed this term to the other side, right? It's plus y. When it goes to the other side, what happens? The sign changes. This entire thing must be multiplied by minus sign. Basically, what happens? What is negative becomes positive. What is positive becomes negative. So this is very important. My bad. So I just realized that now. I'll just remove this over here, just that thing, or you can just change the sign and then you will get the answer. That is, when you take this to the other side, it'll be 0.03, that's positive, and minus y. Why? Because, sorry, when you're taking, the sign changes, positive becomes negative and negative value becomes positive. So here it's 0.03 minus y. Okay, other than that, now how do we solve it? We need to solve dv by dp, right? That is y dash of x. Here, what is the v value, x or x and y value? It's given. It was given how much? 5 comma 1, I believe. Let me just quickly go check back. It is how much? Over here it's mentioned it's 5 and 1. So all you need to do is substitute wherever x is there as 5 and wherever y is there as 1, and then you'll get the answer. I won't substitute manually like over here. I'll just put in the calculator now. All you do, this entire equation, write it out, 0.03, it's 0.03 minus 1 divided by minus 10 into y. What is y value? It is 1, x and y, to the power minus 3. You don't need to put power minus 3. 1 to the power anything is the same thing. But anyways, let me just use it. 1 minus 0.03, close the bracket, plus, what is x? It's 5 plus 5. Over here, y into 1 minus 2. It's the same thing. It doesn't make any difference. Now, what is the answer? It's 9 minus 97 by 30. Let's just write it down and compare. Minus 97 by 30. So that is the correct answer. That is the slope. So you can see. Okay, now over here they have manually done it. So it's negative 0.97 divided by 0.3. Whereas in calculator, you'll directly get the final answer. That's negative 97 by 30. So that is, see over here, what they have asked is, let me just remove this. They have just asked you to find the derivative at this particular point. That's it. The value of this, nothing else, not as an equation or nothing else. You have to just find the derivative of the volume with respect to pressure at this point. So whatever answer you get, that's the answer. But the most important thing is this derivative when you do, right? You must be very careful after you do the derivative. You basically just substitute the answer. Substitute the x and y values and find the answer. It's negative 97 divided by 30. So that is that. And now we go to a crazy part, that is double derivative of implicit functions. It's, this is only so confusing, and they want you to do it 2 times. So it drives you crazy now. Okay, when I was, studying this for the first time, when I was your age or something in school, I used to always, despise this because learning implicit function is hard and double deriving it is crazy. But anyways, we will see it's not so difficult. If you know the concept, it's just applying the same concepts over and over, so it won't be so difficult. Now let's look at this problem. Here we need to first find the y double dash of x. That means this equation needs to be derived once. You'll get y dash of x. And you need to do it again and find y double dash at this particular point. Okay, double derivative. Now we will directly jump into the problem and do it. So this side, when you derive, it will be 2y into y dash of x plus, what about this? We know e to the power anything will be the same thing, so it will remain the same. That is exponential function formula. It's gonna be same thing, but then you have to do a chain rule. Okay, so now let me just write it out. 2e to the power minus xy. This is the derivation of e to the power xy, but it's not over. The function e is over. Now we need to derive the chain rule. What is this power? We need to derive it over here. So I'll just use the brackets. And now it's a product rule. Look over here, it's uv, okay? It'll be u dash v plus uv dash. Now I know this minus sign is gonna irritate us a lot. So what I'll do is, we can remove this minus sign outside because it's just a sign, right? Or it'll be, both the terms will be minus. So what I'll do is I'll just remove this and make this minus, okay? This minus, I'm going to remove it and put it out right now. Now it's basically you're deriving x and y because we have done it many times x and y before as well. So I'll just do it. Derivation of x is 1 into y plus, what is the derivation? This x remains. What is the derivation of y? It'll be y dash of x. If this minus sign was there, both the terms will be negative. That's it. Nothing else. Okay. Is equal to 0. That's the answer. Now, the thing is, it's not over because we need to double derive it. There are various ways to double derive it. You can multiply this inside and then you can double derive it again. Plenty of ways. But what I would do is, just like this, I will double derive it now. Many times you will have to use the product rule. It's up to you. You can simplify this further and double derive it, or you can double derive it just right now. It's up to you. Now here, what happens is the first part is okay. It's simpler. Let me use this color here for the first part. It'll be a product rule. 2 is a constant. You can just leave it out. And what happens here is y will become, uh, you need to derive the first term first. It'll become y dash of x into just y dash of x again, because you have to write this second term as it is, plus, now first term remains, second term derivative will be y double dash of x. Why? Because you're deriving this already derived term again, you're deriving it, y dash of x again you derive, it'll be double dash. That is what we are basically finding, y double dash of x. Now when I'm just doing this, I remembered, this 2's, right? You can see there is a 2 over here, 2 over here, and this is right side is 0, so you can basically divide all the sides by 2 and take this out. So what happens is you can take this common and remove it, or you can just think divide 2 here, here, this 2 cancels, and 0 divided by 2 is 0 itself. So that would be easier. Why? Because otherwise it'll be so many 2's at the end, and when we remove that common and take it to the other side, it's going to be the same thing, okay? But it's just that if it's better you take it in the first step itself over here after I solved it. Wait, let me, now over here after this I'll just repeat. Next step would be take this 2 and 2 outside common, the other terms will remain same thing, and take it to the other side, or divide all the 3 terms by 2, that is left side and right side. You have to balance, right? When you divide 2 by 2, it's going to be 1, so that's gone, this also is gone, and 0 by 2 is the same thing. So that's the reason I'm removing 2. Even if you leave the 2 at the end, you can remove it off, but it'll just be a lot of terms. That's the reason I removed it now. Now this side, it's over, this term is over. Now what about the other term? So left was easy one, okay? Now let me change the color and let me make it green. It's minus, that's outside, let it be. Here it is, this is the u term, this is the v term. First one is derivation of u term. Now look, it'll be e to the power minus xy. Fine. What next? This term, right? Multiplied, chain rule, the derivative of this thing. Now I'll multiply the minus sign because it's two terms, right? I'll multiply the minus sign inside. It's going to be same thing. Derivation of y, x will be 1 y, but remember the minus sign will be over here, minus, and my plus will become minus with this x, so I'll write minus directly, x into y dash of x. Now if you're thinking what's this, we have just done it, right? In the previous step we did this derivative, the same thing. Now this, what I did, when you derive, you're going to get the same thing, e to the power minus xy. Only thing is I multiplied the minus here, I've kept the minus. In the previous case I removed the minus, so it was a thing, it was plus and plus, sorry. Now this is done, u dash is done. See, the derivative of u dash is done. What is v? V is this term. Now multiply this term. I'll remove this, I'll not write 1, I'll write only y plus x y dash of x. There are lots of repetitive terms, right? Next, plus uv dash. Now write this u term as it is, minus xy. And what is v dash? Derive this term. The derivation of this term would be y dash of x plus, now again a chain rule, a product rule, sorry, u dash, the first term will be 1, I'll not write 1, it's same thing, multiplied with this, that'll be y dash of x plus uv dash, so I'll write x into y double dash of x. I hope this is clear. It's x into y double dash of x. If it's so confusing, just visit the previous lessons of product rule, chain rule, quotient rule. These are very crucial here. Now we have got such a huge terms, right? This is the reason I was telling it's a bit crazy at times. That's when you double derive it. Now what we need to do is we need to try to simplify how much we can, and then we need to take all the y double dash terms common out, right? So let's see now. This is the second term. Let me just change the color now. Doesn't matter how many colors I change, it's gonna still be difficult, to understand it thoroughly. Each time you need to analyze, and it's very very easy to go to do, easy to do any simple mistake here. That's the thing. But anyways, now this would be square. Now I'm not gonna simplify anything. Let me just see which terms have y dash first. This is one term. Okay, this is one term, and then this will be multiplied. This entire thing is one term, but this doesn't have, whereas this term has. And now you should remember to multiply this minus inside. Let me rewrite and write it first. It will be y dash of x the whole square. Why? Because it's squared, right? And then, one second, here there's one, two. I'm only getting confused a little bit, but anyways, why did I square this? Because they're multiplied to each other the same terms, that's the reason. Then plus, this can't be simplified, it's y into y double dash of x, that's it. Now here, this negative signs, you need to multiply this to the first term and this term. Remember this e to the power minus xy, those both will be negative, okay? But now you can see there is minus and minus. So I'll remove this minus and minus out. It'll be already minus, and this when I multiply, it's going to be plus. This first term will be plus. I'll repeat again why. Because there is two minus over here. I'll remove this minus and minus, put it out here. These both will be plus. And then when I multiply this minus here, it's going to be minus and minus will be plus. Okay. E to the power minus xy. Now look carefully, because I took the sign out, it became y plus xy dash of x. These both are two same terms. So what I can do is y plus xy dash of x the whole square. Why? Because there are two same terms. Once you remove the minus sign, that's the intention, to remove the minus sign, to make those two terms same and then square it up. Here e to the power minus xy remains. And what else? The first term is done. This minus over here, it will become negative. Since there is no negative or anything over here, I'll just change this to minus e to the power minus xy. Now what next? Here, oh, okay, I forgot about this. This term has to be multiplied here and here. It has to be multiplied. Um, Let me just get this correct. E to the power, this term will be over here. Yes, it will be u into v dash. This entire thing is v dash. Okay, yeah, there is one bracket over here, and then so this has to be multiplied to each and every term here. But before multiplying it over here, I just multiply the negative sign to e to the power minus xy. Can you see this y dash of x and y dash of x are same? So what I'll do is I'll write 2 times y dash of x. If you're thinking why I'm not putting a square, see it's plus. When I plus x and x, it's going to be 2x. Whereas if I multiply x and x, it's going to be x squared. So y dash of x multiplied y dash of x is squared. Here y dash of x plus y dash of x is plus. It'll be just 2. Then we have got x, y double dash of x. That was the term. Now you can see I can easily multiply them inside. So again, I'll have to simplify this. Y dash of x the whole square plus y into y double dash of x plus e to the power minus xy into y plus xy dash of x the whole square. Now minus e to the power minus xy into 2y dash of x minus again, because this is multiplied here and over here, it will be minus e to the power minus xy multiplied with x y double dash of x. Finally we have simplified. Now the goal or the intention is to make sure you group all the y double dash of x and everything else to the other side. Okay. So whatever is with y double dash, I'll leave it over here. Y into y double dash of x minus e to the power minus xy into x into y double dash of x. That will be equal to, okay, this goes to the other side. It'll be minus y dash of x square. Then what next? This will also go to the other side. It'll be minus e to the power minus xy into y plus xy dash of x, the whole square. And this also goes to the other side, become plus e to the power, because it's minus, it becomes plus now, x minus xy 2y dash of x. Okay, crazy, isn't it? And now what I do is I'll take this y dash of x and y dash of x common out. Y double dash of x is removed out, and you're remaining with y minus e to the power minus xy. And now this entire thing will be written over here itself. I hope you understand now. See, now I've removed this out. Whatever is remaining will be divided by this about term. I'll write it out. So I have done a mistake here. See, I have removed this term out and this term out. What is remaining? Y minus e to the power x. But I forgot to write this x, okay? So I'll just add a x over here. It's like such a so many terms, it's very hard to understand what's what. But if you concentrate and do each term very well, double check the terms, because sometimes I write it, I just pause and double check it. Now the signs might vary. If you can have different signs, but ultimately these terms are what that really most important thing. So I'll just remove the y double dash out, and what's remaining over here is y minus, I'll write this x first, e to the power minus xy. Right side I have negative y dash of x the whole square minus e to the power minus xy into y plus xy dash of x, then this whole square, whatever is the bracket, plus, I'll write this number first, e to the power minus xy, and because it's a number, I just wrote it out, y dash of x. That's it. Okay, divided. Now, this is the answer. Now, all I have to do is I have to take this to the other side. I would be really, really, frustrated to write this again and again. So I'll just divide this over here by this term. It'll be y minus x e to the power minus xy. I hope this is correct, because I paused it many times and I double checked each step. Till now, I didn't find any mistake. I'll just erase this. Why? Because I brought this to the other side. Now, this is the answer. Okay, we need to solve it for these 2 points, but let's first check the answer. Where is the answer? Um, Okay, here is the answer. It's negative y dash x the whole square minus e to the power minus xy y plus xy dash of whole square plus 2 e to the power minus xy y dash of x divided by minus, yes, it's absolutely correct. I'm relieved. It's just that you need to be thorough, just double check each step. That is what I was doing when I was solving. When I did each step, I just paused the video again, I just double checked whether I derived everything correct. I realized few things I missed, so I just do it in the next steps. So if you double check each and every time, each step, you will get the correct answer no matter what. It is going to be straightforward as long as you do it properly. So that is the most important thing. As long as you use each and every derive each and every term properly, the signs multiplied properly, and then we get it. Now here you should not forget to substitute these values 0 and 2. So I'll just show you over here what happens when you just substitute. See, this happens over here. Oh, there is one important thing which you must remember. Now we have x and y value, but what about y dash? Now here, all you need to do is, let me just go back. Let me just remove what I've written. Let me just go back and find the first step. See, first we derive once, right? We just did y dash of x plus 2e to the power this thing. Then we derived again and we got all this. See, we got the answer over here wherever I've written. This is the first step. You can see this one, right? Here now, you need to do some changes. I mean, not changes, you need to do the substitution and solve. Look, all because over here it's very messy. Remember, there was 2 and 2 which I removed, I dissolved it, but that's fine. Even if you remove the 2, that doesn't make any difference. I will use this one only. You can see I'll just use the calculator directly. Now, here, the first step, I hope that's clear over here. This one, okay? This step. See this step, this one. Here you need to first substitute the x and y values, and then what you need to do is find y dash of x. So let us substitute the x and y values over here in this step. So it's going to be, what is y value? Y value is 2. Now y dash, I'll keep it as alpha x because that value I'm solving for, right? So what is this y? It is 2. I substituted 2 over here. Y dash of x is unknown. Minus e to the power, shift e to the power minus 0 into 2. Then what is there? This is going to be 1. And what is there? We have y is 2. Y is 2 plus, what is x value? It's 0. 0 into y dash, it's going to be 0 itself, so I'm not going to write it again. That whole thing is equal to 0. Shift and solve. What is the answer? So y dash of x is 0. I hope this is clear now. We have x, y, and y dash value as 1. So x is 0, y is 2, and y dash value is 1. So this is how we get it, all the three values. Now basically, let me just remove. Okay, now basically in this equation, what do we need to substitute? The known values. I will substitute it over here. See, very important to use the brackets. Y dash value is found out to be 1, so that is 1 square minus, now I, okay, let me just type it as it is instead of simplifying. Minus 0 into 2, it's going to be 0 itself, so I'll just leave it as 0, multiplied with what? Y value is 2. Y value is 2 plus this entire term is going to be 0 because x is 0. So I'm not going to, simply type that out, that this will be 0. So it will be just y square, okay? 2 square plus 2 into e to the power, it's going to be 0. Minus 0 plus 0 doesn't make any difference. It's neutral. 0 is neutral. Into 1. Okay, because y dash of x is 1 divided by 2 minus 0. Why? Because when x is multiplied with anything, it's going to be 0. Why? Because x is 0. The answer is negative 3 by 2. Let's just check. Yes, it's negative 3 by 2. And this is how we do double derivative. It's crazy long, but if you follow each step thoroughly, do it slowly, and make sure you are doing the derivative, multiplying signs properly, no matter what, you will get the correct answer. So this is how you solve this part, and you can see in the graph, you can double check it if you want. So this over here, minus 3 by 2 is what is asked in the question. The graphs won't be given. This is just for your understanding, okay? And that's the end of the implicit derivative. And now the last part of this is inverse functions. This is the easy bit. The first one was, see, the implicit derivative is easy, but only when there is lots of complicated problems, it might be difficult, okay? Now we will see into inverse functions. Inverse functions are for trigonometric inverse functions. They are given by these formulas. These are very important for the next term as well because we have this in integrals as well. So please try to remember them. One thing to understand that is always when c, cosine, cotangent or cosecant, there is always minus, right? That stays even over here. You can see wherever there's c, there's a minus sign. And then what about sine, tan, and secant? There is all they are positive, but don't group them like that. Group them sine and cos together. You can see over here it's 1 by root of 1 minus x square, and it's the same thing for cos, but there's a minus sign. But what about tan and cot? It's 1 by 1 plus x square, and it's minus 1 by 1 plus x square. What about secant? Secant is 1 by magnitude of x, root of x square minus 1, and it's minus for cosecant. If you just look at them, you will see the pattern. There is always root for sine and secant. But tan and cot, there is no root. Tan and cot is plus, whereas the others there's minus. But it's very important to understand sine, there is starting with 1 minus. Tan, it's 1 plus. Here it is x square minus. Okay. So this is the thing. Please remember them. And now we will solve problems. Look at them. They have given inverse. All these are inverse. So let's write them problems, and we'll see the difference between all of them. First thing, understand what's the formula for cos inverse. This entire thing is x, right? But the cos inverse is given by negative 1 by root of 1 minus x squared. So all you need to do is do the same. Look here. All you will have to do over here is write the same formula. It will be minus 1 by root of 1 minus, but instead of x we have 3x squared the whole square over. But don't forget, it's not over because there's a chain rule. This is more than x, so you need to do the derivative of this. That will be 6x. Why? Because 3x squared derivative is 6x. So that is the answer. Over here they have just written, see this minus 6x is multiplied with minus 1, so you write it up. And the square, this whole square is there, right? 9 will be squared, x squared will be squared, it will be 9x power 4. Very simple, just simplification is done. Square 3, it will be 9, x squared to the square is 4, you multiply the powers, this comes up. Now derivative would be, this 2 comes down, will be 6x. That's it over here. Same thing you need to follow over here. Very straightforward problems. You have 1 by magnitude of x square root of x square minus 1. What you do over here is same thing. Okay, they have just told derive both of them separately. Oh, now, sorry, I forgot. Okay, I didn't focus here. Look at the square that is outside. So the power rule is first. Why? Because the square is outside the terms, right? Can you see the square? The outermost term is this, then comes inner term. So it will be 2 times, you can see it is 2 times sine inverse x. Then you need to derive secant inverse x. We know secant inverse x is this formula itself. So it will be 2 times secant inverse x and 1 by magnitude of x root of x square minus 1. That's the answer. Whereas for tan inverse, it's one of the simpler formulas because there's no square root and stuff, and it's easy to remember. 1 by 1 plus x square. Here it is x cube, same like the cos inverse what we did. Here you need to write 1 by 1 plus x cube, sorry, because x given over here is not a tan x, it's tan x cube, the whole square. And then derive x cube, it will be 3x square. So 3x square is up, 3 times 2 is 6. So this is how we do inverse functions. Very easy and straightforward. Let's look into a real world problem. This is the last problem I believe in this lesson. Modeling the rate of change of a ball player's gaze. Now here we have a baseball player. Let's read the problem. One of the guiding principles of most sports is keep your eyes on the ball. In baseball, a batter stands 2 feet from a home plate as a pitch is thrown with a velocity of 130 feet per second, about 90 miles per hour. Assuming that the ball only moves horizontally, what rate does the batter's angle of gaze need to change to follow the ball as it crosses the home plate? Okay, let's understand this problem. Now, if you have seen baseball, there'll be a bowler who will be throwing the baseball very, very fast at the batter. And this guy looks into the ball and he sees and hits it. Okay, in reality they don't see the ball till the end because it's very hard. They do because they are practiced to do that, I mean, they're trained to do that, but not always they'll be looking, because they will look at the ball where it's released till over here, and they assume where it's gonna land, and that's how they swing the bat, imagining, okay, based on this wind speed, everything, the ball is gonna come over here, and I'm gonna hit it. But you will see why it's very very hard to keep the eyes on the ball in a while. But first of all, this is the scenario, right? Look here, this part is where the ball is released. This is the baller. The batsman is standing 2 feet away. This is where the batter over here, with the baseball, is standing from this home plate. The bowler's intention is to throw the ball at the home plate, because there'll be a person over here to catch the ball if the batter misses. This distance is 2 meters, and this distance we do not know. This placement we do not know. But they have given us what? The velocity. We have been told the velocity of the ball. This velocity is how much? 130 feet per second. Okay, but it's coming in the downward direction, will be negative sign. Why? Because it's coming towards the batsman. If it is going upward, then it will be positive, but over here now it's negative. The sign doesn't make much difference, it's just the direction over here. Now here, this is 2. Theta is what we need to find. The gaze, the angle. See, now this is the ball player. He looks at the ball now. As the ball is coming over here, he closes in. This is the angle downwards. It'll be negative as well. So we need to see from here to here the angle when the ball comes over here. Okay, which is the trigonometric value that relates the adjacent line and the opposite side, opposite angle, opposite side, and the adjacent. It is tan, right? Tan theta equals opposite by adjacent, that is d by 2. We need theta, so you can just take tan inverse on both the sides. It'll be theta equals tan inverse of d by 2. So this is the thing. 1 second, we will just go further. Uh, this is the d. Now d with respect to time over here. Why? Because that is basically the displacement. Now when we derive this, we are going to get d dash, that is the velocity. Now over here, look here, theta is given. Theta is tan inverse d by 2, that is the distance over here. And we know the tan inverse formula. We have to just substitute over here 1 by 1 plus x square, that is dt by 2 the whole square, into the derivative of this. What is the derivative of x by 2? If it was x by 2, it is x dash of 2, right? Now here it'll be 1 by 2. 1 second. Imagine this was y by 2. You're deriving this. It'll be y dash of x by 2. The same thing, we are getting d dash of t by 2. Why this d dash is important? Look, in the question we had been given, no, let me keep this. In the question we had been given velocity. The distance, displacement over here, derivative of that, it's with respect to time. Sorry, it's x is time here. Let me just remove that. Why is it not going? Okay. D dash of t would be the velocity. Okay, v of t. This is very important because we have studied derivation of displacement will be velocity. That's the reason we are doing this. Now here we can easily solve. We have all the we have the velocity. We can substitute, right? So this is the thing. Now here, okay, this is one more important thing. Now, what is d dash d of t displacement? It's not given. But let's look at the figure over here for a minute. Let's look at this figure. The distance, this distance is unknown, right? But the velocity is known. But what do we want to find is the gaze when the ball is coming towards the batsman. So the ball is thrown from here at a velocity of minus 130 feet per second. And when it comes to the batsman, when it comes over here, what is the d value? D value will be 0 because it reaches over here. Okay, doesn't matter what is the distance. Imagine it was, say, 6 meters. When it reaches this point, it's 0. So when we find this we need to find what? Theta dash. So both the sides when it derived left the rate of change of angle, right? The rate of change of his gaze, left side will be dash as well. Now the important thing to understand is when it comes here, this d of t will be 0. See, all you need to do is substitute what is known 2 times negative 130, that is given, that's the velocity, divided by 4 plus this is 0. Why? Because it's coming towards the batsman where he's standing. So the rate of change of gaze, this angle, because we derived over here on both the sides, we got dash, that is the rate of change, will be just this in the calculator. It will be negative 65. Now, why negative 65? It's coming from the direction. That's just direction. That is the thing. So it's very straightforward. Just use the tan trigonometric function, relate the sides, the opposite and the adjacent side, derive both the sides over here. First, take tan inverse on both the sides. So tan is gone from theta. It's only theta and tan inverse. We know tan inverse derivative. When you derive it's on both the sides, it will be theta dash and here tan inverse d dash. And then substitute the values. Now I told you right why it's very hard for baseball batsmen to look at the ball. That's the reason is here. See, with it has there have been studies that we can accurately track objects which is only 3 radians per second. Now look at this; it's 65 radians. It's such a huge amount than the normal, normal rate of tracking objects. So that is why you need to be such an expert. If you're a baseball batsman, the batter needs to be such an expert in tracking the ball, and it's not possible for tracking the ball all the time. When it's released, yes, maybe sometime, and then you will have to just understand, assume, and then hit it. So that's what it is, and that's the end of this lesson. Finally, such a huge one, right? I hope it is clear these problems. And if you have any doubts, do post them in the comments. I will try to get back to you very soon. And the implicit derivation is not very easy at the beginning, but the more you practice, the easier it becomes. So please do practice many more problems by yourselves, and it'll be easier as it goes. So that's it. A quick reminder, if you have not yet subscribed to my channel, please do subscribe. It would mean so much to me, and all those who have subscribed to my channel, I really appreciate it. And if you have any doubts, please post them in comments and I'll try to get back to you very soon. That's it for this lesson. Take care, guys, and I'll see you in the next video. Bye bye.